We're going to go over assemblies tonight. Um, it's sort of a follow up on what we did last week. Last week we went over parts, making parts with sketches and features. And now we're going to put parts together in an assembly. That's what it's called when you put multiple parts together and define how they are connected or interact or stuff like that. So one of the important things in making assemblies is including components that you didn't make yourself. Often hardware manufacturers and stuff like that will provide CAD files of their products. So it's important to be able to include those in your assemblies because your assemblies will often include products from various vendors. We're going to import our own parts into the assemblies and go over basic mates. So mates are what you use to define the relationships between parts in an assembly. And then some best practices. There are some things you should do and some things that you can do but should avoid. Just because SolidWorks lets you do it doesn't mean you should. And then there's some tricks. There's some cool stuff you can do with assemblies and fancy mates that define complicated relationships between parts. And then we'll get started on assembling the Geneva drives. So that'll be fun right at the end, or not right at the end. It probably won't be too long from now, but then we'll spend the rest of the meeting on that in our breakout rooms.
What are assemblies? Andy touched on this pretty well. It's just a collection of parts and how they come together. So for example, you can see this tire assembly. I don't know what all these components are necessarily called, but you can see they're all concentric. And so, you know, it's a circle within a circle. And so all we are going to be doing is taking all of our individual parts, and these could be, you know, screws, nuts, and bolts, putting them together. But generally, these are individual components that are manufactured or produced individually. And then we'll use mates to define how they're related to each other, similar to the relations that we used in part sketches.
McMaster Carr is really awesome. We use them for everything, and a lot of companies use them for everything because one of the reasons is they make their SolidWorks files right on their website and they give it to you. So you don't have to guess, you don't have to buy a screw and then buy another screw and then do refunds and stuff. You can download the CAD file and then put it in your drawing and then see if it works or not, which is, you know, the best. And you can also download a lot of different CAD files from a lot of different places and a lot of different formats. So that's just things to be aware of. Again, most of it's pretty easy to figure out, but we just want you to know. There's a lot to be said for using CAD that's already there and not wasting time, as opposed to making it all yourself, which might be cool, but is pointless overall. So just be smart about how you do things.
Now we're going to get started in the actual workings of how you make an assembly. The first thing you need to do is basically pick what part you're going to start with. So there's a couple methods you could do to first get into your assembly. You could either be in a part file that you just finished working on and you want to hop right into assembly making. So if you're in a part currently, you can click in the top left in file, and then you can click make assembly from part. And so that's just a nice little streamlined thing SolidWorks has where it lets you immediately hop into assembly, and it will set the part that you currently have open as your origin point. It will basically lock it in space. So that's kind of a theoretical thing that we should talk about really quickly. The way that SolidWorks understands things is basically as a coordinate grid system. So it needs to have an origin in order for it to basically tell where things are relative to that origin. So your very first part that you import is typically going to be what you set as your origin. That's your fixed part. That part will not move in your assembly. Everything will move in reference to that part. So when you first import your thing, make sure that you set it as such. Yeah, so if you alternatively, if you have an assembly open, if you just open up a blank assembly, you could click on the import part button and then basically insert it from there. So it's kind of it's not a very obvious thing that SolidWorks has set up here. You want to make sure that when you first import your part, you don't click somewhere in the blank screen to place it. You want to basically just hit the checkbox and say, hey, yeah, this is the part I want to start with. That will tell it that it's a fixed part rather than placing it somewhere freely in space to move around. And I'll make that more clear in the subgroup when we're actually starting to build it. I'll show, actually, Brian, you want me to just show a quick demo? I think this is pretty important.
Sure. Yeah, why not?
I have my SolidWorks open, so give me 2 seconds. When I was like first learning SolidWorks, this is one thing that was just not clear at all, and it's pretty critical. So yeah, when you first go to make an assembly, I've just clicked new and new assembly. So it's a blank pad here, and I'm like, all right, cool. The thing I want to do is import my first component. So in this case, I insert components, and I want to start with frame half here. So here's the thing, it puts it in place, and that's nice and perfect. But if I move my mouse around, it'll place it somewhere in space and not make it fixed. We don't want that. Don't click somewhere to place it. Make sure that you just hit the checkbox, and then bam, you're all set. It'll be a fixed part, and SolidWorks will be happy from then on out. That's all I wanted to show.
So Ryan told us how to get the first part fixed, but now mates are what you use to get all of the other parts to line up in your assembly the way you want them to. So there's a lot of different mates that you can use. You can, they're all sort of listed here, and we'll be getting into these more when we're actually doing stuff, but you can make surfaces be coincident with each other. You can make cylinders be coaxial with each other. You can make surfaces be parallel but not actually touching, or perpendicular and not actually touching. You can set round pieces to be tangent, all sorts of stuff you can do. When I'm building up an assembly, it helps me a lot to sort of think about how the pieces are physically constrained to each other, and then try and make the mates match up with the way the assembly is actually put together as much as I can, because that just sort of helps me make sure everything's actually mated correctly. Yeah.
Here are some best practices when dealing with assemblies. Generally, it's a good practice to edit parts in their individual part files and then rebuild that assembly later. You know, the default for that, I believe, is Control B. So that just rebuilds all the assemblies for you after you've edited any parts. In general, having fewer mates in assembly is better. So you could, if you have two rectangular parts and you want to, say, make one of the faces of the rectangular part, the first part, basically coincident to a second face on the second rectangular part, you could first constrain the two faces parallel to each other and then assign the coincident mate, or you could just assign the coincident mate and it automatically assigns a parallel constraint. So you could essentially do two mating operations in one mate if you're smart about assigning those mates. So that's something to also think of. How can you do this in the most efficient manner so that at the end of the assembly you have the shortest possible list of mates that you can go back and edit. And you can kind of see on the right there in the top, there's a long list of mates that is generated at the bottom of the feature tree. So if you ever want to go back, you can edit those mates individually. So the mate at the top is the first mate, and the mate at the bottom is the last mate. So it's all chronological. However, you could also expand a part within an assembly and then view all of the mates with respect to that part. And those are listed chronologically as well. So it's an easier way to access mates for a specific part rather than having to fish through that entire list of mates at the end of the assembly tree. So that's a neat trick that I use all the time to just edit certain constraints within an assembly without pulling my hair out trying to find that one concentric mate, near the bottom. It's easier to just locate the part and then expand the tree out and then find the mate corresponding to that part.
Can you guys see this thing?
Oh man, that's a monster CAD, but
Yes.
we can.
Yep.
So here I'll close this tree up. So you can see you've got all these parts over here in the parts tree, and down here at the bottom is the mates tree right here, with all the different mates, and there are a lot of them. and you know, some of them are suppressed and stuff like that because they're from deleted components and things like that. So you know, it's kind of hard to figure out what's going on down here in the mates tree. There's no real organization. So it's a lot easier if you just go into the specific part that you know you need to work with, and then you can see the mates that specifically constrain that part. So, you know, for this part, it's the, you know, this tube right here, and it's got this incident mate here that locks it onto this bulkhead down here. So, you know, I could edit that particularly, something like that. But yeah, that's all there is to that, but it's certainly useful.
Actually, Andy, while you're still on there,
Yep.
I think that's also a great example of how a lot of people will name their parts, but not their mates. So I think you can rename mates, but it's just a lot of time and a waste of time, in my opinion. But naming your parts is critical. And you can similarly name features, but a lot of people don't. And knowing, yeah, you can. So, you know, being able to search for mates as that are related to a certain component is really powerful and lets you find what you're looking for much, much faster, especially if you've got an issue with just one component.
Yeah, and sometimes you can use naming conventions like here to help figure out where parts came from and stuff like that. But advanced assembly tricks. So the top one here is if you set the materials of the components of an assembly, you can use the mass properties tool, and it'll tell you how much the thing weighs. It'll also tell you where the moment of inertia is, or sorry, what the moment of inertia is, and where the principal axes of inertia are, and stuff like that. Give you all kinds of information, where the center of mass is. Very useful tool. And then you can also perform various other studies on it, simulations and motion studies to figure out how parts are going to interact when they move around. So I guess I could show mass properties too, just so that's quick.
Something else about mass properties, and I forgot to put this on the slides, is you can actually specify your own coordinate system with your own origin, and that'll let you find where your center of mass is from a certain point in your part. So you could set the corner of your part as your origin and then know where your center of gravity is compared to that point.
Yeah, that's useful. So like here's the so this is based off the coordinate system centered right here. You can see this red, green, and blue thing, but you could set it elsewhere. Here's the center of mass here, and you've got moments of inertia, coordinates of the center of mass, surface area, volume, mass. You can adjust your units here, decimal places, stuff like that. So very useful stuff. And you can also override the mass too, if you need it for like if some of the default material properties are inaccurate or something like that.
Some advanced mates, you don't need to use these or know them at this point, as far as I'm aware. The only one that you might need to use is width, but and I'll explain that momentarily. But the point in bringing this up is to just let you know that there are, I mean, I think it's actually called advanced mates in the mate menu on SolidWorks, and they exist. They're pretty cool. They let you do some nifty little things, but you don't always need to use them. They're more niche. So for example, limit would let you say that a certain face of a component is able to move within certain bounds. You can set two planes and it can move between those two planes or something like that. Or symmetric, where two faces need to be symmetric around a reference plane. With width, this is the one pictured, you basically can specify the outer faces of a component sandwiched between another component's interfaces, centered between those two faces. But if you ever want to explore them, you can just search like if you Google SolidWorks help and then limit or width, it'll pop right up with the SolidWorks like help catalog, and it gives information based on what version you're on. So it's a pretty awesome resource.
Well, I mean, there's not much to say. We're going to be working on this Geneva drive. You guys all probably saw the GIF in Discord or the video on Discord. It's pretty cool. So we're going to be putting all 4 parts together. So basically, we're going to be putting it together in assembly.